Hello all. In this video we are going to discuss about demultiplexer in digital circuit design. So in our previous video we have seen the multiplexer design, and we have also seen how to design a multiplexer and what are the boolean expressions for the multiplexer. And in this video we are going to see about demultiplexers in digital. So the demultiplexer is a combinational logic circuit that performs the reverse operation of a multiplexer. So the demultiplexer has one input line and m output lines, whereas we have 2 power n input lines and only one output line, whereas in the case of demultiplexer we have only one input line and m output lines, and we have here n select lines. So a demultiplexer with one input and m outputs is called as a 1 to n demultiplexer. So let us see the block diagram of a demultiplexer first. So this is a block diagram of 1 to 2 power n demux. Okay, where n represents the number of select lines. So on n number of select lines and only one input, and we have 2 power n output. So on 2 power n number of output. Okay, so this is a demultiplexer, and we also have one enable signal for this. So the demultiplexer has one input lines and 2 power n output lines, and it also required n select lines. So now let us see example of a 1 to 2 demultiplexer. So a 1 to 2 demux has only one number of select lines. So for determining the number of select lines, you can use a formula 2 power n, where in this case n is equal to 1. Okay, now so this is a block diagram of a 1 to 2 demux, where we have only one input and two number of outputs, y0 and y1. This is a 1 to 2 demux. Okay, and we have also one select line here. Okay, so let us see the truth table of this 1 to 2 demux. So this is our input, and this is our select input, and we have outputs here. So this is our input D, and if the select line is equal to 0, and this is our input D, and if select input is 1, let's see what happens. So we have two number of inputs, one is let's say y1 and another is y0. Okay, so if input is D and the select line is 0, then y1 is equal to 0 and y0 is equal to D. And if input is D and select line is 1, then y1 is equal to D and y0 is equal to 0. So this is how a demux will work. So depending upon the select input, so if the select input is 0, then the input will be occurring at the output y0, and if the select input is 1, then the input will be reflected at the output pin y1. So depending upon the select line only, this demultiplexer will work, and the other output will be simply equal to 0. Okay, so this is how a demux will work. And coming to the boolean expression of y0 and y1, so the boolean expression of y0 is nothing but d into s bar, d into s bar, and boolean expression for y1 is d into s. So these are the boolean expressions for y0 and y1. From this also you can see y0 is equal to d into s bar and y1 is equal to d into s. Okay, and let's see the logic diagram for a 1 to 2 demux. So let's see it. So this is our select line, and this is our input D. Okay, and it's connected to a NOT gate also. Now y0, which is nothing but s bar into D, this is nothing but y0, and y1 is nothing but s into D. This is nothing but y1. So this is a logic diagram for a 1 to 2 demux. Okay. So you can try other multiplexers like 1 to 4, 1 to 8. Okay. So this is your simple assignment. You can try and you can post it whether you can able to. You can post in the comments whether you can able to draw those particular demultiplexers or not. Okay. So coming to the applications of a demux, basically these are used in data transmission. So that's all for this video. So in this video, we have discussed about demultiplexers in digital circuit design. I hope you have got a clear idea about what is meant by demultiplexers. So if you like this video, please like, share, and subscribe to my YouTube channel all about VLSI.